Hello everyone, welcome to this new video for the super user interface using Python to connect with the microcontroller. And this time what we are going to do is to add on the user interface that we have been creating so far, something that will communicate with the microcontroller directly through the protocol. So by connecting here, you will see that we will have here the status OK and also the active channels, plus all the buttons that we are going to need already. Plus, this will be creating the list of the channels that we will play and also the list for the Y data that we will play. So, and like, let me show you also again. So if I choose the wrong baud rate and I put it with connect, you will be seeing that it will be checking and saying this is a message error, nothing, and we will have from time to time a failure and it will be checking. If I go back again and I go through the right baud rate and connect like this, it will be okay and we will be ready and will be generated. This is will be using threading. It will be using a data class, and there's a lot of things that you're learning here on playing with all of them together. But if you would like to understand and to learn how all this library works together, stay tuned and follow this episode. This video will be focusing on synchronizing Python with the microcontroller. And for the tutorial perspective, this is the video number 5, where we are going to complete the serial side of the communication manager user interface. And by that, we can complete the whole part 1 of the tutorial for the communication side. So all the code is available on GitHub. You just have to focus on this video, understand what's going on, and then download it and play with the code as you want. The code we are going to do is only in Python, and the text editor is a VS Code. Finally, you'll need a little bit of knowledge of Python. Of course, I will do my best to explain every step of the code, but having a good understanding will help you to smoothly go through the video. Okay, so from the tutorial perspective, first of all, we are going to take an intro to the thread operation, understand what's going on in a quick slide, just to have an overview. Then we are going to set up the data class. After that, we are going to set up the sync serial using threading, and this is how we are going to synchronize the serial operation between Python and the microcontroller. Then we are going to filter and decode the message, and this is the extremely important part. Finally, we are going to end the threading operation. This is extremely important to have a smooth understanding of how the threading is stopping and also to avoid any problem at the end of the operation. Okay, so let's take a look on the thread operation. Well, this is our timeline of execution of a program. It's just something going through time, and we do have our main program running and managing the GUI and the program logic, whatever going on, to interaction and everything. And after that, we will have using also the main thread updating and display. So that's the normal thing. But by adding a threading, we are going to add, and we do have a data transformation there. But by adding the threading, we are going to have a parallel operation of a new thread. So there will be a program going on in parallel with the main thread. It will not be something inside it. So this main thread will be getting the serial information or the data from the microcontroller. And after that, it will be updating the data. But what will be going on is there will be this update of the data will be communicated to the main thread. And how we are going to do that is to set up a data class that will be transformed and also shared between the two threads. That's where the data class is so powerful. So we can update the data from the new thread and use it in the main one. So now that we do have this idea about how the both threads are playing parallel and we can update the data in both of them, we can go and start setting up the data class. Okay, here we are. We are back at our main screen and we are going to add the file related to the data. So we call it a data communication control ctrl.py. Okay, perfect. And we start creating the class, and let's call this class a data master. Okay, and after that, what we are going to do is to add the initialization function. So init, and we are going just to have the self on this one. Okay, perfect. And the first variable that we would like to use as initialization, let me add them here, copy paste quickly. Those are the variable we will use to synchronize or for the communication protocol. So this self.sync is the one that we will be sending to the microcontroller to get the feedback as this exclamation mark and to be sure that we got synchronized. This one, this start stream is the code that we are going to send to the microcontroller so we can get the stream started. And finally, the S that will be stopping the stream. Finally, the sync channel is the number of channels that we will get from the microcontroller. So let's go back here. So let's save this one first. And we go back here and we put from data control import the master data, the data master. Okay, and let's go here and put my data will be equal to data master here. So now we have our object ready, and let's add my data here. Okay, so we add my data here. So what we need to do right now then is to go to the GUI master and start adding this one. So for serial here, we have to add data, and we will put after that self dot dot data will be equal to data. Okay, good. And then we need also to go to down here and add data because we would like this object to move directly through the whole our program. So everyone will be sharing this data object together. Self dot data will be equal to data. And let's go here where we are going to call this one. So where is it? So this is here. And when we call here self.serial and here self.data. So that will be an object flowing through all the other objects, and we can start using the data class and to start initializing. So now we prepared our data class, we are ready to use it, and we can jump to the next step. So in this new step, we are going to use really serial and the GUI at the same time. So what I will be doing, I'll be hiding this one and I will put the serial here, put it in the left. So we will have a review on both what's going on in both object and how things are going on. So for this one, I don't want to put the serial in the left, that's fine. And I will put the GUI in the right. So when we start running here, the communication GUI, and start the connect, at this place, we are going to start having a certain activity on the serial. So let's put both of them at the same time, and we can start creating the new data for the new function actually or method to get the data from the stream. So let's call this one a serial sync. So let's go here and put a def here, def, and we call it a serial sync. So this is because we would like to synchronize, and this one will get, it will be a self using the self because it will be using all the data inside the serial and also the GUI. Good. And after that, what we are going to do is, so this serial, it will be a loop, an infinite loop until we get the result we need. So to start and end the loop, we will add a self here dot threading like this, and that will be equal true. And as far as this threading is equal true, that will be the loop will be running. And this one will be extremely important because it will be controlling this thread working or stopping. And also, we will be counting each time how many times we are going to do this. But let's keep it for later on. So what we are going to jump here is starting our loop. So while our self.threading here, so as far as it's true, what we are going to do is to try. Why am we need to try? Because let me remove this print zeros. Yeah, sometimes going for shortcuts is not really that good. So we are going to try first of all to self dot ser here and write. So we are going to write ser dot write. So we are going to send the data that we do have inside our data class. So what we are going, so GUI, because we are getting the GUI and we will see it later on. So when we are going to call this method, we will give the GUI information on it. So GUI dot data dot sync here dot encode. Okay, so that's the important place or part that we talked about previously about encoding the message from Python so it become how to say readable from the microcontroller. So we are going to do this, and this will send the message and the sync message that we do have, which is here. This is our sync message that our microcontroller has been programmed to understand and decode by itself. And then what we are going to do, and you see this is the GUI.data.sync encode. So this is it from the data object, and then from the sync that we do have in the data object, and then encode is a basic function from Python. After that, let's play a little bit with the graphic user interface to see the power of what we can do. So we put here con, this is about the connection GUI, and what we are going to add, we are going to call, so if we go back to the GUI here and go to this one, we do have, not this one, the con, which is in the con GUI here, and we are going to call the sync label so that we put equal sync. We are going to add same thing. So we are con dot and after that sync. Let's copy it here just immediately. So it's a sync status for our sync status here like this. So even though it's already in sync mode, you will understand we will be showing that we are synchronizing right now. So sync status text this is equal, and we are putting exactly, we are going to put this sync. Okay, and after that, what we are going to add is we are going to add the foreground here, or the font color, so here FG, and we put orange. We keep it as orange as we're still synchronizing. And what we are going to do is to keep like reading the data, so GUI dot data like this dot decode. Now, before decoding, we have to read it first. So GUI dot data here dot raw message like this. Okay, equal. So this is a new one that we are going to create, and that will be a self dot ser, and this is from our serial code, our serial object, and we put read line. So read line means it will read the message that we are going to receive when it will have the end of line or the /n char. Then we will put GUI dot data dot decode. And what we can do, actually, not a decode, but let's print it. Let's print this one, print, and see what we are going to receive. Okay, so that's a part one. So for the except, what we are going to do here, and that will be very helpful for you guys, because when we put try, is a very good to avoid any issues happening here. And we will have, as sometimes the message is wrong, sometimes we are not receiving nothing. So there is a lot of things that can go wrong. So we can put here exception as E, and we are going to print the E, just in case, to be sure that we will understand what's going on. Good. And so if things don't go as we expect, so if our while we are not getting what we want, and this is here where it becomes interesting and to make a really good debugging activities. So first of all, what we can do is to put a count at the beginning here. We put a count equal 0. This is just to initiate how many times we are going. So going to make this check. And after that, we put here a count plus equal 1, a little bit of fancy code. And what we can do, if our count is greater then self dot count or the sync count, let's say self dot count, and we can right now start making this one. So let's go at the top. That will be something that we will be managing on the top here as the initialization goes well, and we put equal to 100. We will make 200 times this test and be sure if we can connect or not. So if it's greater than that, so first of all we will put count equal to 0 again, so we can restart. And after that, we can update this graphical interface to tell to the user that something is going wrong. So the text here will be failed, not anymore sync, so we'll have failed, and that's why I kept putting this one here. And for the color, let's put it red. Okay, so we do have this one, and if we don't put a little bit of weight, it will be quite difficult to see it. So we put time dot sleep, and we put a 0.5 second, just enough to be sure, but we don't have time. Let's import time here, import time. Okay, fantastic. Okay, so far so good, but if we don't close this one from now on, we will have a big trouble. So we need to put some escape like code from now on, else this loop that will be running later on in the threading will never end. So let's put here. So if the self threading, we need to put it just in case, is equal to false. Okay, then immediately you break. Whatever the step here, and I quite advise you to put it as much as possible, and you'll understand. I will give some other explanation later on to keep this to break at any time. So, and also here. Okay, so if threading is equal false, we break immediately this loop and we close our program. Perfect. So after that, so we do have this one going on well, but what we need to do now, and that's the interesting part, is to call this in the threading. So let's close this one here and go back. So let's put this one here. So when we click on the connect button here, we do have all this stuff that we have reviewed together, and immediately after successful connection that we will have, and we create or we call this object here, so what we can do is start a threading. So let's put a self dot serial, we call it enter serial dot t1, that will be equal, and then we will put threading like this dot thread, and here we will put a target. So let's start target is equal, so now we are calling the self dot serial, and we can copy directly this function. Yeah, so let's make this. And after that, be careful, don't put the parentheses, else it will start immediately in a way that you don't want it. So, and after that, for the args, so we need to add the GUI. So the args will be equal to self. So we are going to send this object, the self object, not the serial. Okay. So within this self, just a moment. So the argument here, we are going to send this, sorry, not here. Let's close this one. The GUI object as a self. That's what we are going to send. Let's go back. So let's go back to this one because we close it. So after that, there's another very important element in this threading is the daemon tool equal true. The daemon is the function that will say to the threading, hey man, so if you do have trouble when you are shutting down, you close everything, because threading and sometimes program that really independent from the main core, and if it's not closed properly, they keep running, they keep doing some problems. And this one is not threading but threading like this. So it's extremely important to keep this one running in closing in a proper way, and the daemon is the one that will close it if something bad happen. And I really advise you to add this function. Okay, so self. After that, we need to run this small beast dot t1 dot start, and this is how you run your threading. And what is great is that threading is a function of Python, is a core function of Python. So let's put here threading here, so we can put from, we just import threading, that's all, import threading. Let's save. Okay, we have done everything. We can start. No, I'm joking. We should never start our threading before we have the how to close that. And how to close it, it's simple. So where we connect here, so if we are going to connect, we will run our threading. When we are going to stop, we put serial here. I think you know what I'm going to call here, not serial, sorry. It's a self dot serial dot threading, which is here, so I don't make a mistake. Here, threading, and I will put it equal files. Okay, this will stop our program, but still we will have at the end a section. It's very important how to finally secure the threading if we have any like a non-expected closure or something. So this is a kind of the main, but we will need to add some stuff to secure it. Okay, I think so far we are good. We are ready to make a first run and to see what's going on, but let me recheck again. Are we going to bring the data? Yeah, we are going to see what we are going to receive. And normally this program will keep failing because we didn't put any success condition here. So let's run our program. This is our beautiful GUI. Go to the com, we go to this one and we start running. So we do have a problem here, daemon, okay? And it's right, daemon. So why the daemon is not working well? Let's go back. Where is it? Not this one. Yeah. Let's make this one bigger to see what is going on with my daemon. Daemon equal true, but daemon is A and E. I should have focused more in English when I was high school. Okay, let's run again. It's good to have bugs, so to see what's going on and try to find what is the issue. Okay, let's connect. Okay. Yeah, you must be hating me right now, guys. I'm so sorry. Okay, let's run again. This time it would be working. Yeah, it's working. And you can see it's trying to synchronize, failing and failing again. And if I put disconnect, it stops. There's no issue at all. And the program here, you can see it's sending and working perfectly. So we are sending a code, nothing is going on, and we are waiting. You see it sent error, and sometimes it sent the right code, sometimes not. So here we're receiving the right message, where sometimes not. And that's why we are going to the next step, where we are going to decode what's going on and avoid to have any issue through the communication protocol. We are going to focus now on the data file and also the serial. And as you have seen in the previous part, we have been receiving the data, but we didn't really be able to decode it and to understand it well. So what we are going to do, first of all, is to start create a certain method using the data one to decode the data in the way that we want. So let's start creating this one, and we will call this one let's go for the method, and we call decode message. We will put self, and we will start creating this new method. So first of all, what we are going to do is to have this variable temporary variable, and we will be equal to self dot raw message that we got here. This one, we are going to decode this raw message like this, and we are going to use the decode Python function like this, and we are going to use the UTF-8 encoding one. Okay, so first check if the len of temp, so we have to check if the temp is okay, is greater than 0. Then we are good. We can go through the decode. After that, if we do have a hashtag, and this is something we have seen, and that's what we will use for separation, is in temp. So we do a hashtag in temp. So then we can create our new list, which is self.message. So this is our primary message. It will equal to temp, yeah, temp.split. And we are going to use the hashtag. Okay, so sorry, here the hashtag as a separator, and that's one that will be used for the split. So if hashtag, what's going on again? So this one is greater than 0. I think that will correct everything. Okay, so we are going to split. So let's print message here, print the self.message. And after that, what we are going to do, because this hashtag, as you can see, we do have an hashtag here before the E. So we are going to delete the self.message and the 0, the first indexed one. Okay, and let's print it just to see what will be going on. So print the self.message. Okay, so we have this part clarified. So what we can do, and simply just rerun again and see what will be the result of the test. Okay, so let's go like this and go for this one. And after that, we start running and we start getting the message. So let's disconnect. And you could see I didn't close the GUI because if I do it right now and the thread is running, I'll have trouble. Okay, so I should have put it like something before, but where is it? So right now I'm receiving. Okay, I keep receiving, but am I getting inside? Actually, I don't think I'm getting it. And of course, because I didn't put it here. Yeah, it's very. So what we have to do is GUI.data.decode message. Okay, let's run it again. Let me put some names so we can understand what's going on. So here, let's put like this and like this, and we put F like this, and we put raw message to make it more easy to understand and read. And after that, here for before, let's put it like this again and this again, and we put an F so we can read what's going on, and we can put here before removing index, and same stuff. We can exactly copy this one because we just do that this one instead of before after. Okay, so far we think we are good, so we can go and check now. Before that, let's save here and let's run our GUI. Go to the COM3, use the baud rate of the microcontroller, and we start. Let's show you the result here so you'll get better understanding of what we got. So this is a message we got. This is a correct message. The other one are wrong, but this is correct message. So we got this message from the microcontroller. We start removing. So here, this is the new list. And after that, we removed the first one because we don't need it. And here we can start getting the data here for the check and this one for the number of channels. The program is working perfectly and we can see the message that we are receiving. So I can start removing this one and also this one as we don't need this for debugging purposes. and we can go back again to the serial. So now that we decoded the message and we do have this self.message, and what I will do, I will initialize this self.message here just in case, and not message 0, but self.message, and it will be equal to this one. Okay, so we got the self.message. So what we can do, so we start by doing the first check. So if GUI dot data, and we are getting the sync OK, let's give it the sync OK here. If this one so is in GUI dot data dot message of 0. Okay, so if we do have that, then we have to check again if int of GUI dot data dot here, and but message, it's a list, so message of 1 is greater than 0. Then we will put a pass here. We should be good. So the first check, we are checking that this one, the exclamation mark, exists in 0, the index 0 of my list, like this one. And after that, we are checking that the second one here, if we put it to an int, it will be greater than 0. And if there's any problem, like you have an E here or something else like this / something, that will generate a problem and not continue the execution. But if we do have this 2 we are good to go for the next step, which is start updating the GUI itself. So now what we can do is go back a little bit here. So we are going to jump to the GUI data here, the GUI data here, and we are starting to update some of the stuff. First of all, we do have, let's make this one a little bit bigger, like this. So in the this one, in the this one, and we start, we do have a lot of, the start stream is disabled, the stop stream is disabled. We start enabling every one of them because now we can use them. We are going to enable everyone besides stop stream because this one will be enabled only when we start the start streaming, and also the safe check one. So let's quickly start taking here. So first of all, it will be GUI.con, and after that we can quickly start copy from here. So the start stream like this, and we are going to put state here, state, and equal to active. That will be the same for a lot of other one. So let's copy this one here, and we are going to just later on update them. So 1, 2, 3. I think, yeah, there are 4 that we need to active. So stop stream, no, but add button chart, this one. So we will put this one here, and also button kill chart. Still not convinced with this name. Okay, kill chart, and after that the save check. So now all these ones are active. That's really good. But what we can also add is here, getting these ones here and putting them. So right now we don't have any sync anymore. It's okay. And we are in a green situation. So here we are in the green. Okay. So after that, we need to add also some update for the check status, which is this one here. So the check status, it used to be for this one channel status, it used to be like 3 point, but now what we are going to do is to put GUI.con for this one, the check status, add it here, like this, and this one's text will be equal. Yeah, we can put it. It is equal to the not the int, because that needs to have the how to say, it needs to have a string. So this will be equal to this. And another one, we need to also add another new, another new parameters that will be in the data one. So GUI dot data dot, and we call it the sync channel. So if we go here to data, it's now the sync channel is equal to 0. Okay, but now it will be equal to this int, and this is the number of channels that we do have. Okay, so now we have the number of channels that we need to work and construct our all the charts. Okay, so this is here we have updated everything, and what we need to add just to close. So there is two other functions that we need to add. This is to build the data and to prepare it. But before that, just to make a check and to be sure, so we will put self dot threading is equal to false. So to quit this, and after that, we just break. Perfect. So let's close and check the result. It should be straightforward, but we're never sure. And let's go here and connect. And we are good. Just one thing, I think here, the status is not working well. So why this is not going to be green. So why the FG is equal to green. Yeah, this is sync status. Not sync status, it's a channel status. It's the one that I need to change here. This is okay. This is here I need to change. I have to add, or not status, but I have to go here and add like this. The FG is equal to green. Okay, let's go and take a quick look on how the result is. We should be good. Connect. It's working and everything is in green. And you can see this bottom are working properly. The start and the stop is disabled as we expect. Okay, the two last steps on this part of the video is to start getting the number of channels or getting the channels. This is really simple. So we are going to the data here. Let's go and open the data here. Let me go and in this one, so just a moment. So we add a new one. So this will be used later on to generate the list of data that we do have. So let me work on it. So def, here we call generate channel. This is to generate the list of the channels that we have. Channels like this, and it will be accepting only self. We don't need really to other things. So what we can do is self.channels. Well, let's go into a capital C, channels. That will be equal. So it will be a list. And stay tuned a little bit with me on this one. So it will be a list of strings, and these strings we will put ch for channel, including here the number of the channel that we will put here, ch, and ch is generated for ch in range of self dot, and we get the sync channel here. So this one will generate the list of channels that we do have. So it will be a list of strings that will be ch1, ch2, ch3. So I hope this one is not too complicated for you, but it's extremely handy to write. It shows the power of Python. So let's put here, we remove the comment, so it will be a GUI.data.gen channels like this. And after that, and that's a method. After that, we are going to add another data that will be, method, not a data, that will generate the Y channels. So now we are going to visualize our data. So it means we will need to have an X list and a Y list at the beginning. After that, we will go through transformation. So let's add them right now so we can have the X and Y for us. So we call them here the X data and Y data, so self dot, and we can put the X data, it's an empty list at the beginning, and also self here dot Y data, let's put here like this, it will be an empty list. Okay, good. So what we are going to do right now is to go and build the Y data. So let's go here and put a def, and here build, let's use it like literally Y data, and we will be using self. Okay, not a self, but a self. And for this one, it's simple. We were going to have a loop. We can use also the same writing we have done for the previous one, but I enjoy using different type of Python. So put underbar, and in the range of also self.sync, like this one, same range. What we are going to do inside the Y data, repeat, like be clear with me, it's inside the Y data, it will be self dot, and the Y data, what we are going to add to it is an append, and we are adding a list. So we will have a list, inside it we will have 4 lists, and this will generate for me the lists that I will be updating when I will be getting the data. Because as you could see, we will see later on actually that we are receiving now, we do have a 4 channels input in our microcontroller. So let's put it here. And what we are going to put is self dot, yeah, self dot, and data dot build the Y data. Okay, Y data. And we are good. So like this, just I think that's perfect. So what I will be doing, just in case, let's print both of them to be sure that everything is going well. So I put self.channels, but I will change it quickly. That will be a self, it will be GUI data. And this one is also GUI, not self. Okay, so let's put GUI data and also again GUI data, and we would like to see the Y data here. So we should have it only once, and this is when everything is generated. So let's take a look on the final result. Let's connect again and connect. Okay, so I'm having failed, something not rowing well. Yeah, and fortunately I have the one, so I don't have the gen channels. So let's disconnect and go to gen channels. Did I saw there's no object called gen channels. Gen, yeah, of course, so I forgot to put this one. So that's why it's really good I'm putting here, not in this one, putting all the exception as an E, so I can immediately understand what's going on without having my program crashing. So that's very handy and very useful to use try, and this is really good practical example. Let's try to do again, and we'll go to the COM, go here and connect. Okay, so the str cannot be interpreted as an integer. Okay, let's disconnect and find where is the issue. So here, invalid name, label 2. Let's check quickly. I do have, where is it? They say, where is the problem? So str goes, of course, because sync channel is an str. Okay, let's check again. Yep, that's a mistake. So int, here I need to put not this one, data channels, it will be an int of this one. That's what they generate the issue. So let's try again. It's a good exercise, as I said, to be sure that we do have everything correct and to see how I do the debugging. Yeah, and it worked perfectly this time. So we do have channel 0, channel 1, channel 2, and 3, and we do have a list of 4 lists that we do have here, and this is the one that we are going to use later on to build the data to be displayed. That's perfect. So now we do have everything good to receive the data, to manage it, but we still have to close this function if something happened, or to restart from again. So let's go in the next part where we are going to see how to close the threading, how to close also this data class again. So this is the final part of the code where we are closing and cleaning the system if there's a threading, and also from the data. So let's go and start. So we close this one. We don't need any more. So the serial perspective, we are good, but we need to first go through the data and close it properly. So let's here go for the data and add another method. Here we call it def, and we call it clear data just in case, and we go through self. We don't need any other things. So when we start here, we would like to put everything back to 0, or the one that we are not really using. So let's put self.row data, or row message actually. So self.row message is equal to nothing. So we have to clean this one, and also self.message just in case is equal to nothing, and self to y data is equal to the empty list. So using those ones, we clearly clean the data and clear it. And after that, we go let's close this one. We don't need it here. And we go back to the GUI that we do have right here. So we are not anymore in the area where we would like to connect, but we would like to see when we disconnect, and we call it here. So we add self dot data and dot clear data. So using this one, we are clearing the data. But right now, we are going back to the most important step, which is properly closing our GUI, and this to avoid any issue with the threading. So let's go, and first of all, let's bring the master here. So what we need to do is to include the serial data here, the serial data, and also let's add the data itself to the master GUI, or the root master. So we will put my serial and my data here, and after that we go back to this one. So now we don't need this one anymore, and we close this and we close this. It's so nice to have everything organized like that. And we put in the self, we will add the serial and the data, so the object can flow through all of them. And we will put here self dot serial is equal serial, and after that self dot data will be equal to data. Okay, so now we need to initialize a new operation under the root. So this one is self dot root dot protocol, and this is something related directly with the Tkinter. And for this protocol, it says when something happened, I would like you to do that. And this one of these happenings is when the window is deleted or closed. So WM and then delete window. So this is one of the protocols. This is when we close the window. What I want to do is to have self, and we will create a new a new method called close window, like this. Okay, so let's create this method here. So def, and we call it close window, and it will be here only self. And during this one, let's start by printing here, like closing the window and exit. So closing the window and exit. Okay, perfect. So, and after that, self dot root dot destroy. So we destroy the root like this. And after that, we add self dot serial, the one that we created, and we put here serial close, the one that we created. So we are going to close the if there is any connection. So we probably ends with the input, so the serial communication. And after that, the final one, I guess you get it, self.serial.threading is equal to false. And this is a core key important step. So we need to close this one and to put threading to false. So if we do have any threading running, we will be able to stop it. Okay, so let's go. Okay, we do have serial and data are missing, of course, because I didn't safeguard it here. Saved, okay. Let's go now and make try. Come and here we connect. Good, let's close. Okay, it worked properly. So we don't see those one, sorry, we don't see those one happening because they are discrete one, but everything went smooth and we could close with no issue. So because if we closed and we had the threading, that will be, we will not be able to see this line. And this one will be extremely helpful when we will have later on the streaming and somehow the program crashes or something happen. Okay, I think now we completed the whole tutorial. We have been quite seeing a lot of things. I hope it was not heavy enough. And see you for the next episode when we will start really try to get the stream and prepare the GUI and prepare the stream and show the data. Thank you so much and see you next episode.